Now we will hear Dr. Tobias Heinen from GREAN GmbH. He is one of the co-founders of that company, but he's also managing director now. And this company has existed for 13 years now. And if you take a look at the website, it says that it is a consulting company that plans and shapes and optimizes factories. So I think this describes your portfolio very well. Mr. Heinen is an engineer and economist, and he studied in Hanover in South Africa, and he also wrote a PhD thesis because it's well-fitting, planning of socioeconomic change properties of factories. So over the next 20, 30 years, I think that we really need those properties or characteristics. That's an important process. I look forward to your presentation, and I'm curious about climate-neutral factories. Go ahead. Thank you very much, Professor Dr. Faulstich. Thank you very much, ladies and gentlemen, for having me. And we haven't really talked about what we're going to present, but I think it's quite fitting because Mr. Weiss presented the big picture of the entire industry. And now I will break it down a bit further. I will dive a little bit deeper because we will take a look at the individual factories. And I want to describe how a factory can become climate neutral. So which steps are necessary in order to reduce the climate footprint of a factory, and how can I achieve this transformation towards a climate neutral factory? So before I get started, I would like to introduce myself and my company. Mr. Professor Faulstich already mentioned it. We are a planning and consulting firm. We are located in Garbsen, that's very close to Hanover. And we are planning new factories. We are also realizing these new factories up until they're up and running. So we are actually the contact point for the industry for the planning and optimization of entire production units. The overarching mission that we have is what you can see on the screen, the zero-emission factory. So we have the production industry, and this industry has a huge climate impact, and we want this climate impact to be reduced and ideally to be zero in the future. So the vision is to have the zero-emission factory. We want to build a production system that has no emissions, which has a zero carbon footprint, and that is why we selected this picture of the green production, of this green factory. So how do I get there? Companies have existing structures, they have made investments, they have their existing fleet, their existing buildings, and they cannot just change the factory overnight and build a new factory, or at least only the fewest companies can do that. So the question is, how can I do that? Which steps do I need to take in order to achieve that vision? And I want to make some recommendations or suggestions how to do that. I will also give you some examples, and I also have some studies I want to show you. So if you are working in a production company, if you are responsible for that topic, I hope that I will have been able to give you some insights or some ideas how to move towards this zero-emission factory. Let's get started. I said that I want to make some suggestions how to do that and to also show you the process. And I would like to present the different steps. We have 4 steps. First, you have to capture the current climate footprint of your factory, because you first need to know your greenhouse gas emissions. Only then are you able to also reduce your emissions. So first you have to take stock. You have to know how much emissions are caused by a factory. I will tell you how to do that and what a good process could look like. And after knowing where you are, where you stand, it is the right step to first reduce these emissions. We already heard a lot about energy efficiency today. We also heard about different approaches. So those are the so-called low-hanging fruits. It is about reducing emissions in a simple way in order to already optimize your carbon footprint. However, later I will also show you some figures and I will prove what I'm saying. I say that this is not enough in order to have climate-neutral production, climate-neutral factories by 2040. I think this requires much more effort, and this is what we call transformation. So it is about changing entire processes. We need to change the entire basic structure of a factory. And then we will also be able to achieve much better results in order to reduce our climate impact. However, the efforts are also higher that are connected to that. Later, I will also tell you what might be possible approaches. I will also tell you what is state of the art, and I will also tell you what might be possible in the future. After having done that, you will have already focused on your situation. You have calculated your footprint. You have defined measures in order to reduce your emissions and transform your factory. However, at the end of the day, it might be the case that you still have CO2 emissions left. And then the fourth step, you can still focus on compensation. This is rather controversial, and some people are very critical about that. But it's possible to compensate for CO2 emissions. So even if you reduce and transform, there will be a remaining CO2 emissions quantity which can be reduced to zero in order to compensate for that, or through compensation measures. But first, I think it's best to really focus on your factories. So let's really focus on the first three steps: capture, reduce, and transform. So let's continue with the first step. And the question is, how can the CO2 emissions and the carbon footprint be systematically calculated or defined? There are different approaches for that. And I think the most popular calculation is the greenhouse gas protocol, GGP. I think most of you might be familiar with that, but I want to present it to you anyway. This is the official chart of the greenhouse gas protocol. You can download it from the internet. You see the different scopes here, according to which the greenhouse gas emissions have to be assessed. And first, the core of everything are the direct emissions in your factory. Those are the Scope 1 emissions. So just imagine that you have a gas heating where you burn natural gas. So you are emitting CO2 emissions in your building. So you have your heating system, you have your own fleet. Everything is summarized in the Scope 1 emissions. Those are direct CO2 emissions. But there are also so-called indirect emissions. And those are emissions that are caused by purchased energy. So let's just imagine you have a factory in Stuttgart, and then you buy electricity from the utilities company. Then the utilities are actually producing the electricity for you, and then this is indirectly assigned to you because your production is indirectly responsible for these emissions. Of course, the electricity is not generated in your factory, but you are using that electricity, and that is why it's assigned to you indirectly. I just want to explain Scope 1 and Scope 2 emissions a little bit. I think it's quite simple to calculate these emissions because most of the companies have good billing documentation about the energy costs. And if you already calculate the Scope 1 and 2 emissions, you already cover the corporate standard. So you should always get started with these two scopes, Scope 1, Scope 2. That's rather simple. And this brings me to the more difficult point, which is scope 3. And those are the upstream and downstream activities. So scope 3 includes all the upstream and downstream activities, everything that you purchase from your suppliers. This is upstream. And downstream covers all the emissions in your distribution chain. And just imagine you are a machine producer or a metal processing company here in Lower Saxony. It might be the case that you buy metal sheets from ThyssenKrupp, and then the CO2 that is bound in these metal sheets have to be included in the scope 3 emissions. So you can already see the big challenge in terms of scope 3. You only have limited access to that information, because if you call ThyssenKrupp and ask them, okay, how much CO2 emissions are included in this metal sheet, it might be the case that you get an answer. However, it might also be the case that you don't get any answer at all. And if you get an answer, you might not know whether the data is correct. So the data quality, the data availability, everything is rather limited. So that is why most of the companies don't do that as a starting point. But just imagine that you assessed your carbon footprint gate to gate, from the incoming goods to the outgoing goods, and you know the carbon footprint. And now you know a specific number of CO2 equivalents, tons of CO2 equivalents. And this is then the first step towards the CO2 neutral factory. And the question is, how can you reduce this carbon footprint that you've calculated? And this is the second step. And I would like to make a suggestion. I would like to show you a great study from PricewaterhouseCoopers. Most of you know PwC, it's a big consulting firm, and they dealt with the question how companies from different sizes and industries, and also producing companies, how can they systematically reduce their carbon footprint beyond energy efficiency? Because we also need material efficiency, we also need a circular economy. These are all topics that play a major role in manufacturing companies. And the core result of the study is the following, what you can see on the screen. The study describes 3 different principles. You can see them on the left-hand side. And based on the 3 principles, there are 10 strategies that can be implemented. I will just show you a few examples. If you're interested in that study, you can also download that study online. And if you're interested, just approach me. I can give you a link, and then you can download it. I think it's very interesting because it considers the entire life cycle of a product. So you can see in the center that the product is produced from raw materials. It's designed, it's processed, it's produced, and then it will be distributed to the customer. The product will be used, and then there is a loss of value. And based on these principles, there are very specific recommendations for action. So there is the first strategy. You can see that right on top. So the prioritization of renewable energies, the prioritization of renewable resources, this is the first principle. And if you do that in terms of raw materials procurement, you could think about a circular procurement system. What does that mean specifically for a manufacturing company? Very simple example from practical life. We accompanied a company, they are a logistics company, and they bought materials and then they sold materials. And of course, all the materials are packaged, there are card boxes, and they actually had the incoming goods, and then they shredded the raw materials from the packaging material, and this was then the raw material for another product. So this is a very simple idea for circular procurement. You don't need any filling material, so the shredded material was used as filling material for further packaging for the outgoing goods. And there are several other ideas that can be considered in production and in your entire value chain. So those are very specific strategies in order to reduce your carbon footprint, and if you're interested in that, just approach me and I will give you the link so that you can download the study. But now let's focus on the core topic. Because despite all the efforts and approaches to reduce your carbon footprint, I believe that you will never reach the objective to have a net zero factory. In order to achieve that, a much bigger effort is required, and this is what I mean by transformation. What do I mean by that? I have a very practical example here. We accompanied a customer in the food industry, and they need a lot of energy and heat because they need to heat up the food products, and then they have to cool them down later on. And for the heating of materials, a lot of natural gas was required. So you can see the volumes here. You have 21 million kilowatt hours of electricity consumption and 139 million kilowatt hours of gas. So it's a huge amount of gas. And now just follow this green line. You see the original situation in 2018. This is 100%. That's the baseline. And the green line is declining continuously. And this green line says that since 2018 up until 2050, this company will reduce the resource use by 1.2% every year. From 2018 to 2050, 32 years, a reduction of 1.2% every year. And then, on top of that, we also considered the change of the German electricity mix, because the German electricity sector becomes greener. And then, this will result in the end of the green line, where you still have a lot of emissions at the end of the day. However, if you are able to take this amount of energy out, this is almost impossible. So despite having done that for 32 years, you will have only reduced your footprint by 50%. And that is why you need much more. So that is why I would like to focus your attention on the red line. So in between, you need those jumps, those dents. You need to reimagine processes, you need to transform processes, and you need to reduce entire factors. So this is what is meant by the red line. And then you might quickly wonder and ask, how can I do that? How can I drastically reduce my footprint in order to achieve these big jumps forward? So it's about changing our mindset, rethinking the system. So, for instance, we have been discussing the question whether we could imagine a factory that is using no gas at all. And this is actually a revolution in this context, because right now they consume 139 million kilowatt hours of gas. This is how they produce the heat, and some part of gas was also used in order to produce electricity in a turbine. But if you want to change that and do without gas, this is a huge revolution. It's not like changing the lighting system to LED. So this is a question that will be discussed much more passionately. However, this will also result in a huge change in terms of the transformation.
Now, here's something that I'd like to recommend. Some proposals that may be interesting for you to understand where to identify those transformation leapfrog steps, if you will. So what you could go for. This is what we did, and we recommend those 5 typical steps. Now, you have to read them from the bottom up to understand what we mean. So the first one, which would make sense, is to convert your power supply to renewables. So go from fossil to renewable. I mean, that's a very traditional way. Maybe put your own solar panels on your roof, or maybe generate power from a wind turbine, or use hydro power. So available technologies, in other words, use those that are marketable. Now, if you get solar power, it's climate neutral, so it balances out at zero, so it could systematically reduce your carbon footprint. But at the same time, you use a well-established factory. I understand those of you who are building factories today, everyone's putting their rooftop system on top of it. I mean, it's not rocket science anymore, but it's the right step in the right direction. Use existing established technologies. But the problem is, with that, you will never going to cover your electricity consumption with solar. Just remember that earlier example with the 20 million kilowatt hours of power? Well, you work 24/7 in your factory, so 3 o'clock in the morning, you cannot generate the electricity you need because the sun's not shining 3 a.m., right? So you're going to resolve part of the problem, but not all of them. So this is why we're proposing the second step, so even more transformative, which is developing new heat sources that you have not used in the first place. So in this case, you want to reduce your natural gas consumption. So maybe use CSP, concentrated solar power, or geothermal energy. Now, here in northern Germany, we did an investigation for geothermal energy of more than 100 or several hundred degrees of hot water further down. I mean, you have to drill 3,000 or 4,000 kilometers deep into the earth. But if that was going to happen at some point in the future, it's certainly a feasible option to replace gas. But to be honest, this is not available across the board. So this would be maybe an option for the future, but not right now. The next one, we recommend electricity-based heat generation. So imagine your entire factory goes without natural gas, only electricity. Well, can you do that? So can you generate huge amounts of heat using electricity? Well, yes, you could, with industrial-scale heat pumps, for instance. So use electricity to produce enough heat, and then you can completely decouple from natural gas. Now imagine you use that electricity for that heat generation from renewable sources. Well, then you come very close to a climate-neutral factory. Well, obviously, we said before, the sun might not be shining at night. Well, it's not shining at night, so you need an accumulator. That's point number 4. You want to use storage systems for electricity, but you can also get storage systems for heat energy. There are bimodal accumulators, both heat and electricity. Siemens, for instance, offers a storage solution that heats up volcanic rock. Volcanic rock can absorb heat, and it has a high heat absorption capacity. So use that volcanic rock, blow air through it, and get the heat out again once it has been stored. So these systems exist, but as far as I know, they're not really marketable across the board. They are really something to roll out in the future. So I don't know if any production facilities can use those. And the next one, the final one, you can always look for alternative energy fuels. Now, similar to how Mr. Weiss, I'm thinking about hydrogen here. If you can replace natural gas not with any of the previous technologies, well, then you replace that with neutral, i.e. climate-neutral fuels. And I share the view of my colleagues that hydrogen is something that is not yet available on the industrial scale, but it might be a solution going forward. So anywhere between level 2 and 3 is, I believe, where the future will be. And all of these are steps that I thought could be worthwhile considering and that we recommend in order to make factories climate neutral. And finally, this may be sounding confusing. It's like a big motorway. You don't know where you're heading. Do you need to go straight ahead, left or right? And I think that's an understandable feeling that many people have at the moment. But let me tell you, this is an exciting time that we live in. And because people need to realign their business models, and rightly so. And this is what these exhibitions, those big trade shows are for, and this is why you need to talk to colleagues. And with that, I would like to close. I would like to thank you for joining us here today, and I'm looking forward to our discussion later on. So for the moment, thank you very much for listening.